Hello my dear students, welcome to the class of 11th English Medium. The subject is Statistics, Chapter 3, Measures of Central Tendency, brought to you by Vitan sir. In the previous tutorial, I explained the concept of median for the raw data and the discrete and the continuous frequency distributions. Also, in the previous tutorial, I explained how to calculate median for the raw data. You can find that video on the top right corner of your screen. In this tutorial, I am going to start with some illustrations based on discrete as well as continuous frequency distributions. Starting with illustration number 20. The following record shows the absent students of class during a month. Find the median of number of absent students. Simple. The data is given through a table. The number of absent students or the absent days will be X and the number of students will be frequency. The data is 0, 1, 2, 3, 4, 5 and then total number of students are 8, 12, 18, 9, 5, 1 and the total number of students are 53. What we need to do first is to calculate the cumulative frequency using the given frequency here. How we are going to do that? The first frequency here is 8, then add the next frequency 12 into 8 we will get 20, then add the next frequency 18 into 20 we will get 38, add 9 we will get 47, then add 5 it will be 42 and then at the end 53. So always remember that the last value of the cumulative frequency will be the total number of the frequencies. So last CF is 53 and the total is also 53. So it's okay even if you don't prepare the total column, but I will be preparing for the sake of information. Now we are supposed to calculate median for this data. Median here is the value of n plus 1 upon 2 observation, and the observation here are 53. So 53 plus 1 upon 2 observations, that would be 54 upon 2 observations, and that is the value of 27th observation. Now the 27th observation you are supposed to find in the CF column. How we are going to do that is this, as you can see, the first has the 8 frequency, of course 27 is not there. Next is 20, of course 20 does not has 27. Next is 38, yes, between 20 to 38 you can find 27. So 20, after 20 comes 21. So the 27th observation lies between the frequency 21 to 38. Okay, and that means this particular value has our median value. So 27 lies between 21 and 38, and this 21 to 38 belongs to the observation 2. Always remember, these values are not your answer. Your answer always lies in these values. The variable, this is just frequency. Frequency does not has your answer. Your answer is in the variable X. So when you get this CF 38, that your 27th observation lies in the CF 38, your observation here is 2, and that means your median value is also 2. So the median of your question, the median number of absent students is 2. Okay, so first use our formula of n plus 1 upon 2, find the number of observation, find the number of observation in this particular CF. Now why I did not take 27 into 47, because this contains frequencies between 39 to 47 where 27 does not lie. 27 lie between 21 to 38, so I have to take this particular value against which the observation is 2, so my median value is 2. I will take one more illustration, you will get it better next time. Illustration number 21, the time required for typing a report by different typists is given in the following data. Find the median typing time using it. Okay, using the data we have to calculate the median typing time. The data is given as time for typing, that is X, number of typists, that is frequency, 10, 11, 12, 13, 14 total. 5, 7, 8, 15, 5, and total number of typists are 40. First we need to calculate the cumulative frequency. The first will be 5, then plus 7, 12, plus 8, 20, plus 15, 35, plus 5, 40. As you can see, the last of CF is the total of the frequency. Now we have to start with the median, that is the value of n plus 1 upon 2 observation, and n is 40 here, so 40 plus 1 upon 2 observation, that would be 41 upon 2 observation, and that is 20.5th observation. Now there is a slight problem. 20.5th observation basically means that 20.5 actually lies between 20 and 21. Okay, 20.5 is in the exact center of 20th observation and the 21st observation. But if we find 20th observation, it is here. This is 20th observation, and the observation, the variable for that 20th observation is 12. Whereas for 21, 21 goes to the next observation, that is 21 to 35, and the variable for that is 13. Okay, so that means right now we have a value between two variables, that is 12 and 13, because the observation is 20.5, which is between 20 and in the next 21. So we have to write a statement that the observation for CF20 is 12 and for CF21 is 13. So the observation for CF20 is 12 and 21 is 13. We need to find an average, just like in the previous tutorial. So 12 plus 13 upon 2 is 12.5. So your median is 12.5. So whenever there is a value which is not included in the CF, but rather it is distributed over two different CFs, we have to just get an average of both the values. That way it will be easier to, it will be accurate calculation. Moving on to illustration 22. The number of checks deposited per day in a bank has following frequency distribution. We have to find median number of checks deposited. Okay, so we have to calculate the median number of checks deposited in the bank. The question is given number of checks and number of days. The checks number is, as you can see, are in the classes, and the classes are then again not regular classes, they are inclusive classes, so a little tweaking will be required. The frequency is there. Now the next thing which we need to do is find the cumulative frequency for that. 2 plus 14 16 plus 23 39 plus 7 46 plus 4 50. So the last value of CF is equal to the total number of days. Okay, that is the total of frequency. Putting this value into the median, but before that let me clarify, if in case you don't know, just go to the top right corner of your screen. Actually that video is the previous video from that, in which the method of calculating median for the continuous frequency distribution is given. In this continuous frequency distribution, we have to follow a formula, and for that we need the median class. Here we don't have a single observation in the number of checks here, rather we have the classes. So first we have to decide which class has the median value, and so we don't calculate median here, we calculate the median class first. And how to calculate that median class? The class of n upon 2th observation. Now in the continuous frequency we don't add 1, that means in the raw data and discrete data we take n plus 1, but in the continuous frequency we just take n. The n here is 50, so the class of 50 upon 2th observation, that would be class of 25th observation. Now from the CF, as you can see, the 25th observation would be in the 39. So when it is in 39, the class here will be 80 to 119. So from CF we can see the 25th observation lies in the class 80 to 119. Now we need to calculate using a formula, and for that formula we need 4 measures. The first measure is L, that is the lower limit. The second is F, that is the frequency of the median class. CF is the cumulative frequency before the median class, and C is the class length of the median class. Now, L is the lower limit point of the median class. Median class is 82119, but as you can see, these are the inclusive classes, so we need to deduct 0.5 from the lower limit. So we will take L as 79.5. The frequency of the median class is 23. The cumulative frequency before the median class, this is the cumulative frequency of median class, this is before median class, that is 16, and the class length of this class, as you can see, 0, 40, 80, 120, 160, the class lengths are 40 each, so the class length is 40. We will put all these values into our equation of median, that is L plus n upon 2 minus Cf upon F into C. The L is 79.5, n upon 2 is already 25, we have calculated. Cf is 16, divided by F is 23, and into 40. We will deduct 25 minus 16, that will be 9 upon 23 into 40. So 9 upon 23 into 40 will be 15.65, and when you add it, it becomes median is equal to 95.15. So just write a statement that the median number of checks deposited per day is 95.15 checks. Moving on to the next illustration. Illustration 23. The data about monthly expenditure on petrol for 75 families is given in the following table. Okay, find median expenditure on petrol. We need to calculate the median expenditure on petrol for the 75 families. The question is expenditure on petrol and number of families. Up to 200, okay, then up to 400, okay, up to 600, up to 800, up to 1000, and up to 1200. As you can see in the question, this is not a discrete data, but this is a continuous data with cumulative frequencies already given. This does not depict a class, but rather a cumulative frequency has been provided here. The 2, 8, 17, 32, 57 and 75 are the cumulative frequencies. What we need to do is we need to convert these classes into regular frequency distribution. How we are going to do that? First we need to write expenditure on petrol and number of families, that would be F. Now the first class will be as it is up to 200, but next will be 200 to 400, similarly 400 to 600, 600 to 800, 800 to 1000 and 1000 to 1200, with the last one as the total column. How we are going to convert the frequencies? As the first class was as it is, the first frequency will be as it is 2. Then we will start with the deductions of the frequencies. That means second is 8 frequency, so 8 minus 2 will be 6, then 17 minus 8 will be 9, 32 minus 17 will be 15, 57 minus 32 will be 25, 75 minus 57 will be 18, and when you make a total of all these frequencies, you will get 75 frequency. Okay, so once we have got our regular frequency distribution, we just need to make a column for CF. Actually it will be the same column as the above value, 2, 8, 17, 32, 57 and 75. Okay, clear? So once we are done with this, we have to start with the regular sum, that is finding the median class. Here, because this is a continuous data, the median class will be n upon 2, and that would be 75 upon 2 observation, meaning 37.5th observation. Now 37.5th observation, as you can see in the CF here, it will be in the CF of 57. So 57, because 37.5 completely lies in the 57, the class here will be 800 to 1000. So the median class is 800 to 1000. We need to calculate 4 measures, that is lower limit, that would be 800, the frequency, that would be 25, the previous CF, that would be 32, and the class length, that would be 200, like this. So lower limit is 800, frequency 25, CF 32, and class length 200. Putting all these values into our equation of median for continuous data, 800 plus 37.5 minus 32 upon 25 into 200. Let's simplify this value here. 5.5 upon 25 into 200 is 44, and the answer is 844. Writing the statement down, the median monthly expenditure on petrol is rupees 844. Moving on to the last illustration of this particular tutorial. Illustration number 24. The level of air pollution in particle per meter in a city on different days is as follows. Find the median level of pollution in the city. The data given is level of pollution in, of course, ppm and number of days. 250 or more, this sign basically means 250 or more, 270 or more, 290 or more, 310 or more, 320 or more, 330 or more, and 340 or more. You can say or more or above. The number of days are 150, 133, 108, 76, 41, 20, and 7. As you can see, this is also a cumulative type frequency distribution. 250 or above, then 270 or above, the whole distribution is to be converted into a regular frequency distribution. So for that, again I am preparing a table here, level of pollution and the number of days. Now the first class is 250 or above, and its above is 270. So the first class will be 250 to 270. Now in the previous sum, I did not change the first class because it was less than. That means there was nothing less than that. It was infinity, and so the frequency was also not changed. But the class has been changed. 250 or above has been changed into 250 to 270. That means the frequency will also be found using the difference. 150 minus 133 is 17. Okay, so that way you have to write down all the frequencies, but before that, classes will be 250 to 270, 270 to 290, 290 to 310, 310 to 320, 320 to 330, 330 to 340. But 340 and above means it's infinity, so we just write down 340 and above. This kind of distribution is called the open-ended distribution, where either in the beginning like the last sum or the end like this sum, there is no limit. It goes up to infinity. So in these cases, we actually cannot calculate arithmetic mean, and even if the question was not asked about which kind of average to be used, we must have used the median because there is no other option, because these are the open-ended classes. The frequency will be found using the difference. 150 minus 133 is 17. Similarly, 133 minus 108 is 25. 108 minus 76 is 32. 76 minus 41 is 35. 41 minus 20, 21. 13, and the last one, the frequency will be as it is 7. We have to find the cumulative frequency, that is 17 plus 25, 42 plus 32, 74 plus 35, 109 plus 21, 130 plus 13, 143, and plus 7, 150. That means the total frequency, the last value of the CF is 150. That means the total number of frequencies are 150. Using that data, we have to start with calculating the median class here. Class of n upon 2th observation, that would be 150 upon 2 observation, meaning 75th observation. Now as you can see in the question here, the CF which has 75th observation is 109, the class is 310 to 320. So from CF, 75th observation lies in the class 310 to 320. So the lower limit point here will be 310, the frequency will be 35, the CF before our median class is 74, and the class length is 10. Putting these values into the symbols L, F, CF, and C, and putting these values into our equation of median, we will get 310 plus 75 minus 74 upon 35 into 10. That would be 1 upon 35 into 10, that would be 310 plus 0.29. Answer is 310.29. So the median of the data for the level of pollution will be 310.29 particle per meter. So I hope you guys got the illustrations properly, the discrete and the continuous distribution. Next time I will also teach you guys the remaining positional averages, that is quartile, decile and percentile. So stay tuned for that. Welcome students to Vitan Sir's Unacount Academy. That's better way to success for you. I am Vitan Vora and I teach accountancy, statistics and social science. You can contact me on my cell number 919426310184. Please give a sub to my channel and also check out my other video playlist which you can see on the screen. Thank you and I will see you in the next video.